Hello, I'm Peter Ballant from Technikon. Welcome to this special video interview series where we talk with experts in the field. Today we're looking at the Safe4RAIL-2 project. This is a multi-million euro project which aims to improve the passenger train here in Europe by streamlining many different functions of the train. But we are here to focus on the brain of the train. Actually, it's known as the TCMS, or Train Control and Monitoring System. Today, it's a network of wires. Tomorrow, wireless. That's the goal anyways. Here to tell us more is Julián Andrade. Welcome, and tell us a little bit about your role in Safe4RAIL-2.
Thank you, Peter. So I am a member of the advisory board in Safe4RAIL-2. So basically, the advisory board provides technical guidance and oversight of the project. So we meet once a year, and basically during the meetings we discuss on the project progress and provide some technical advice.
Okay. And what is your day-to-day work outside of this project?
So I'm a solution manager at the European Competence Center of Huawei Transportation Business Unit. So basically, we support Huawei transportation business in Europe, okay? And actually, we cover different transportation sub-industries like airports, roadways, seaports, but we have a special focus on railways, where we mainly provide expertise on railway wireless systems like GSMR that we have today for train-to-ground networks, or LTE that's also used in metros, and 5G that's coming now, and we are starting to see some projects and some opportunities with some railway companies across Europe.
So you're actually perfectly suited for this kind of job to be on the advisory board for Safe4RAIL-2, sounds like. Now let's go back a minute. I mentioned TCMS, or the brain of the train. It controls many functions such as brakes, lights, doors, safety equipment, and air control. And that's a lot. And this project is looking at steps towards a new generation of TCMS, which has wireless functionality. We could say a wireless train backbone. Do I have this right? And what kind of challenges does this bring?
Yeah, okay. So now, I mean, moving from a wired network in the train to a wireless network, of course, has many different challenges. Some of them were existing already with wired networks, but some of them are new. I would say that first challenge is safety, right? Of course, there's a lot of safety critical systems in the train. And the main requirement for the train is to ensure the safety. That's priority. So it has to be ensured that even under failures of the communication system, still is not impacting safety. This is also happening in wired communication, but now with wireless, we have additional failure modes, like not only failure of equipment, but also maybe failures due to the radio conditions, but like interferences or fading and so on, right? So basically there are new ways that the system can fail and has to be considered by upper layer functionality, ensuring the fail-safe functionality of the system, okay? As well as safety, of course, security is a critical concern now with a wireless system where basically it's using a spectrum that can be accessed by anyone. You have to ensure cybersecurity, you have to provide encryption, you have to provide access control to the network and so on, which is probably going to be more strong requirements than you have with wired network, sorry. The other aspect is reliability, which is quietly related to safety, of course. So you want, in case of failures, that the train is still working. And I mean, the last thing you want to do is take some safety measures like stopping the train, right? So that has to be very, very rare to reach that point. So you have to ensure that the system is very reliable. You have to use redundancy architectures, ensuring that the system is fault tolerant, right? And now in a wireless system, you have, as I was saying before, you have now new potential failures, not only coming from equipment failures, but also coming due to the randomness of the wireless communication, right? As I was saying, you may have interferences and so on. You may have temporarily loss of the transmission due to the radio conditions. So it's very critical that you have mechanisms to recover transmission even under the worst radio conditions. Actually, I mean, this is not new because wireless networks has been used in railways for a long time, mainly in train-to-ground networks, right? So we have now GSMR to connect the train to the ground and to the control center. But in this case, the radio environment it's very controlled, right? You have base stations which are statically placed in locations. Of course, the base station side, they have high towers that provide very good coverage. You're able to control very well the coverage along the track at every point, and everything is in a very controlled environment, right? Now, when you move to the train-to-train communication and to the wireless TCMS system, now we are talking that there will be wireless communication between different points of the train, right? Like in a train composition between different consists of the train. So that means that the environment it's much more dynamic. In this case, both points of the communication are moving. It's not so well controlled. The train will move into tunnels probably, or across cities with different fading conditions and so on. And it's not so easy to control this kind of situation. So of course, it's very important that the wireless technology it's reliable. It's reliable against this kind of fading movement and so on, right? Another challenge I see it's in terms of capacity, right? So when we have a wired network in the train, basically we can reach very high data rates. There is basically no main problem with capacity. However, when we go to wireless systems, we are limited, especially by a spectrum. So even if the technology is able to get very high data rates by using the latest technology advance, still, well, we may have spectrum limitations, right? And that may be a bottleneck in terms of capacity, right, for the system. And now new generation TCMS, it's going to demand much higher bit rates than we've seen in the past, right? Another aspect is quality of service, especially delays. So for the TCMS, the requirements are to have delays in the order of few milliseconds, and typically wireless technologies, because the way it worked with the access medium that is shared, and then you have to listen before talk in order to access the wireless channel. That means that there are additional delays that you don't find in wired technology. So it's also important to minimize these latencies and delays, right? So what I would say in summary is that very important to consider security, reliability, capacity, and latency. And I think that's one of the reasons that 5G is fitting well into this wireless TCMS concept, because these are the kind of challenges that actually 5G is addressing.
Okay, so I think maybe that answers my next question, which is what are the features in 5G that are being evaluated or utilized as part of this project?
Right, so as I was saying before, so 5G provides, first, a high capacity, right? So with every new generation of cellular networks, we've seen an increased capacity. Now 5G is the latest one where we are reaching gigabits per second. So that's the first thing that's really required for wireless TCMS. And the second thing, as I was saying, 5G was designed especially focusing on industry needs. And industry needs are mainly related to reliability and related to latencies, right? It's not only a need of transportation and railway industry, but also from other industries, and it's very well addressed by 5G technologies, right? So it looks like 5G actually fits quite well into this into the railway industry. Actually, 5G it's also the best candidate technology for the train-to-ground network. So right now we are in the process of defining the evolution of the GSMR networks to FRMCS, which it's going to be probably based as well on 5G, right? And regarding wireless TCMS, the project, what has done is they did actually a survey of different wireless technologies and compare against the requirements from TCMS, and the best fit was coming from 5G technology, which is called V2X. Okay, V2X means vehicle to everything. It's a technology that was designed for the use of the automotive industry, and it's used to implement the connected car concept, right? So the main original use of V2X technology was to interconnect the different cars to share between the different cars information about car position or movement or trajectories or sensors and so on, right? So improving the safety and evolving probably in the future to the autonomous or driverless cars, right? So will be this technology V2X, 5G V2X will be an enabler to these autonomous cars. In this sense, this 5G V2X, I think it's a very good base for the wireless TCMS, in the sense that first, it's a technology that was designed to communicate directly between devices, right, without the need of network infrastructure, right? And that's going to be very important for the trains, because there may be lines where you will have train-to-ground coverage, and maybe you can rely on this network, but there may be secondary lines without any really wireless coverage from network infrastructure, and still you need to be able to communicate internally the TCMS system. So it's very important to have this kind of functionality. And second, it's based on 5G. It's a 3GPP technology. As I said, it's going to be the same kind of technology that is chosen for the train-to-ground network, and it means that it's going to be compatible, right? So probably there can be synergies, and there could be a cooperation between V2X network deployed inside the train with the FRMCS 5G network for the train-to-ground network. So, like for example, the infrastructure network can be used to schedule traffic in the V2X network, in the TCMS network. So you can rely on that and probably achieve better performance and better capacity with the cooperation with the train-to-ground network, right? And then, of course, when you look to the cases of the automotive industry that they are defining for the 5G V2X, you see that actually there are cases that are quite similar to some cases that we see in the railway industry. So, for example, one of the main cases for the 5G V2X is the platooning, which means basically that the vehicles will travel in line and ultimately maybe autonomously, just with one driver in the front vehicle and a set of vehicles following that first vehicle and be driving autonomously. And that looks very similar to the virtual coupling case in railways, where again you will have also many train sets in line, but not physically connected or attached to each other, right? So actually it may be a lot of similarities between both industries, and I think it's a very good base technology to start exploring for the wireless TCMS. Of course, there will be many use cases that will need some adaptation for the railways. So there may be to build some functionality on top of that, just to cover all the different cases and requirements of railways. But at least I think it can provide a base technology for the wireless transmission in the train.
Okay. And what kind of infrastructures would be replaced with wireless in the case of Safe4RAIL-2?
I think at least, of course, the moving to a wireless communication system, it's going to I think at the end it's a matter of that it will reduce costs, right? So imagine, I mean, we will have two different kind of networks in the wireless TCMS, one at the train backbone level connecting consists in the train. For that case, of course, the use of wireless technology is going to simplify the coupling of trains, creating the train composition. It's going to be much faster because you don't have to connect lines and cables. It's going to be maybe more reliable because you don't have failures in the connection points between the consists. So I think it's going to improve, and it's going to save time, of course, in the coupling of trains. And at the end, it will enable this virtual coupling concept that we were mentioning before, right? So it will probably increase the capacity drastically in the trains. And then at the consist level network, when you look to the different elements in the consist that may be connected by wireless technology. So I guess that wireless system will be not completely replacing the wired communication system. They will probably coexist. I guess that in a first phase, there will be a lot of maybe non-safety systems that could be taking advantage of the wireless consist network. It will provide flexibility because you don't need to take the you don't need to take the train to the workshop to recable everything every time you install a new system. So installation or improving systems will be much faster. And also in terms of maintenance, the fact that we have wireless connectivity is also to simplify maintenance tasks a lot. So probably a lot of advantages will take place. And I guess in the future, it will start replacing even wired communications in safety critical systems as well.
Okay. Well, even though we talked about just one slice of Safe4RAIL-2, this is really exciting stuff. And we wish you success as the project wraps up in the next few months. And thanks for taking the time today.
Yeah, thank you. It was a pleasure.